Today I want to show you how to uh, clip an input to a shapefile that has multiple features in it. And we'll use Python to do this, so something you could implement in QGIS if you wanted to. So I'll show you kind of basically what we're going on here. So right here I have an 8-digit, this big outline is an 8-digit hydrologic unit, and the little ones are 12-digit hydrologic units. And I want to take this digital elevation model and clip it to each of these 12-digit units. But what I don't want to do is have to do this by hand and do it 21 times. That's how many of these there are. I want to just input this and have automated and create a new folder. And this is some of the tasks I found myself doing quite a bit. And so I wrote a script for it, and I think it might be useful for you as well. So what you're going to do is, I'm using PyCharm here. You can see I have those two files right in the project directory, so things will work out nicely there. So we're going to use GDAL to do this. Let's get our imports. First we want to import OS, and then from OSGeo import GDAL. I don't think we need OGR. The first thing we'll do is write the function that does the actual clipping. So we're going to do, we'll call it clip raster with polygon. Okay, we want a raster path, a polygon path, and an output path. Okay, and we're going to use the OS system call. We're just going to use the GDAL command line tool and make a call to os.system with those parameters. And so we want to use GDAL warp, set the node data to -9999, make it quiet. We're going to use cut line, okay, and then we're going to put in the polygon path as the parameter for cut line. And then we've got, make sure there's a space there. This needs to be formatted exactly as you put it into the command line, so mind your spaces. I've had problems with that before, where I forgot a space and it ruined everything for a minute until I figured it out. And then we want to make it a geotiff. Go again, add the raster path. Add a space, and add the out path. Okay, so that's all that function is. That's what we're going to call, we're going to put that in a loop and call it multiple times. Okay, the next thing we need to do is we need to make all of those 21 features their own individual shape files. That's the best way I figured out to do this. If anyone has found a way to just clip without clip to the extent of a feature without making that feature its own shapefile, be glad to hear about that. Once you write the code, it's not a big deal to do it this way, though. So we need the input shapefile, and then we need a field name to do this by. Okay. So what this function is going to do is it is going to take, I'll go over here, it's going to take this input shapefile. It's going to break them out. It's going to break out each of these features into its own individual shapefile. For each feature it breaks out, we're going to make a new directory corresponding to a field name of this feature. And that's going to set it up so that we can then loop through each of these individual features, and then we can clip the raster to those features. Okay, so that's how we're going to handle this. So let's go back over to our code. And first we need to get our driver. And this will be an Esri Shapefile driver. And open our shapefile, which is our in path. And then we're just going to check and make sure the file opened. And we'll just print a message if it didn't. And then ideally we just throw an exception if the file wasn't open, but we'll skip that for now. So I want to loop through the features in that layer. Get the field value. So we want to get the field of our input field parameter. And then we're going to make a directory. So os.mkdir, and let's see, we're just going to make it the same as our field value. So this should just populate over here in my project directory. It should just populate new folders named after each feature. Yeah, actually, the more I think about this, let's we'll come down here and we'll do os.mkdir, and we'll name it clipping features. So we're going to make this new directory before we run these functions. What we'll do here is we'll do clipping features plus that. Okay, and that we'll just have it contained within one little thing, and it's not so crazy over there. Okay, and so we're going to make an output data set equals our driver. We want to create a data source, and we're going to make that in the clipping features plus this, and then we're just going to call it clip dot shape. I need to make sure I have a forward slash there. Okay, so we've got that. Now our output layer, we need to get that going. So we're going to create a layer in our output data set, and we're going to name it field value. I'm going to create a layer out of this actually. Slash clip dot shape. Okay. And then we want to set the spatial reference. Let's see. Did I not do this? Oh, I forgot to set a spatial reference up there. We'll go up and set that real quick. And then our geometry type. Equals ogr.wkb polygon. Okay, so I do need to include OGR up here. I did not do that. And maybe it's GDAL that I don't need in this instance. Okay, so I don't have spatial ref, that's why it's underlined in red. I forgot to include that here, so we'll go spatial ref equals layer, and we'll get the spatial reference of that layer. Okay, so now that should be good to go as far as that part goes. And let's get the layer definition. Okay. And that definition just gives us the field names and the structure of the layer so we can create a new one from it. And we're going to get our input geometry. Our get geometry reference. And our out feature is going to equal OGR dot feature out DFN, our output definition, and then we're going to do out feature dot set geometry, and we're going to use our input geometry, and then we're going to do our output layer dot create feature out feet. Okay, so let's walk through what we've done in this loop here. So for each feature, we're going to read our specified field value. We're going to then make a folder the same name as that field value. So this should be a unique field. It should have unique values in it. Okay. Then what we're doing is we're creating an output data source. So we're creating a new shapefile within this directory we created called clip.shp. Okay. From inside this shapefile, we're creating a new layer, which is actually going to hold all the data. Okay. And we're just showing that we're creating this layer the same as the data source. It's going to be the same file. We give it the spatial reference from the original layer, and it's going to be a polygon type. Now what we do is we have this output layer, and we're getting the layer definition here. Okay, so we're taking this layer definition, assigning it to this variable, which we'll use later. And then we get the geometry of the input feature. So of this feature here, we're getting its geometry. We're creating a new feature, which was what we need that output definition for, so we can create a feature that will match with the layer we're adding these to. And then to that feature, we will set its geometry to the same as the input feature. And then we go to this output layer, and we create a feature, which is the output feature. Now, it seems like a lot to do one thing, but this is creating a single shapefile with a single feature that we can then put into this function to clip. Okay? All right. So, we're about there. The next thing we need to do is create a function that actually calls these to clip things. So we'll call this clip rasters. And the in path, which is going to be the input shapefile, and the field we want to use. Okay, and then we need to get a driver again. So same thing, driver shp, ogr.get driver by name, and this is Esri shapefile. Okay, and we've got that, and now we need to open our input driver ds dot, oh, what am I doing here? ds equals driver shape dot open and our input path. Okay, and then we need to open our dem dataset, or DEM, so dem ds, and we do need GDAL dot open o2. Oh, that's the wrong thing here. This is let's see. Oh, this is just the name over here, which is going to be login Actually, the thing we might want to do here is, let me just double check this. I think we just want to input this as a parameter to this function. I'm going to check that real quick. Okay, so we shouldn't actually need this raster data set. We'll once again just check if this opens. Shouldn't be a problem. And then lyr sort layer equals the data set. And we're going to just do get layer. There's only one layer in there, so we'll be fine. Okay, so now we need to loop through all the features in this layer again. And clip. So we'll do about the same code as before. For feature in layer, get the field value equals feature dot get field of the field name. Okay, and then we're going to do clip raster with polygon. And what we're going to do is we are going to give it the name of the DEM here. So this is my Logan Huck 8 dem 10m dot tiff. Okay, and then I need to give it the path to this, so it's going to be clipping features. This is going to be string field value. Okay, I need to give it an output path, which is going to be, actually, we're going to put it in the same folder here so we don't get them confused. We'll know which folder goes with which clipping layer, and we're just going to name it the dem.tiff. Okay, that should just about do it. Now all we need to do is set things up to run this function. So make this little run section here, and we need to create the clipping polygons. I want to make that an S just because I feel like it. Okay. Oh, I put it in the wrong spot. That's wrong. That goes there. That goes there. That goes there. Okay, good. And then we need our input path, which is going to be the Logan River Huck 8 shapefile. And we need our field, which is going to be Huck 12, which is an identification number for each individual Huck 12. And then we need to clip rasters, and we need our path again. So Logan River Huck 8.shp, and we need our field again. Huck 12. Okay. So we'll try to run this here now, and it should hopefully work. Something you can do, this is a little redundant, is you could probably maybe fit this all into one function just by closing the data set and then running the clip on it right afterwards. Might be a little more efficient on the code, little less redundant. You can also obviously put in these variables put these in as variables so you're not typing the same thing out again, and the same thing here, I have an input parameter to the output directory. Then it cuts out some of this. This is just kind of your proof of concept in the way you can customize this and modify it as you see fit. But let's try to run it, see how it goes. Click run. Yes, that's the one I want to run. And here it goes. Unknown option name. Okay. So we're getting an error. I did something wrong with the command line here. It's because I have a space next to the Q. Let's try that again. Oh, it's because clipping features already exist. So if we take that, we delete it, then we can run it again here. And nothing's happening. So we're hoping it's going. It says it's finished. Our folder appears. We open up clipping features. We now have all these folders in here, and we've got clipping shapefile, and a DEM. We can go over into QGIS, just check some of these. We'll just check a couple here. Make sure it's did what we expect it to. So we have a DEM there, and we have the matching polygon. And so you can see that now you have those lined up in that folder. Like I said, there are a number of ways you can change the automation on this to fit your needs, but it's something that's been really useful for me. Hopefully it's useful to you too. Have a good day.